I'm very much aware this is the last session of the day, and I'm sure you're all keen to move forward to the bar and prepare for this evening's entertainment, but please bear with us for a couple more minutes. I'd like to start by thanking Nuffield for the opportunity to study a scholarship and the late Malcolm Isaac for his very generous sponsorship. As you can see from the title, I'm going to be talking to you today about cherry production and principally the options of mechanical harvesting. I'm a fourth generation cherry or fruit and arable farmer from the Thames Valley based 20 miles west of London. As such, I've grown up around cherries, and I've always been amazed by the beautiful blossom in the springtime and the delicious tasting fruits in the summer. And if I'm honest, I think there's something really sexy about cherries. My family have been growing cherries for over 100 years. My grandfather planted tall trees, so the fruits had to be picked from long ladders. My father planted dwarf varieties, so the fruits could be picked while still in the ground, before I applied covering systems to protect the crop from adverse weather conditions. The UK is currently 21% self-sufficient in cherries, over 15,000 tonnes imported annually. Could the future of cherry production in the UK be mechanical harvesting? With the advancement in robotics, artificial intelligence, and increased understanding of plant physiology, what will the cherry orchard of the future look like? It was this question that led me to apply for my Nuffield Farming Scholarship. My study was to focus on the production of sweet, fresh cherries. As part of my study, I wanted to visit cherry farms around the world to understand what production techniques are currently being used. I also wanted to visit growers of other fruit and vegetable crops whose harvests have already been mechanised to see what could be learnt. And finally, I wanted to visit research developers and machinery developers to understand what technology has been developed for the future. Now, cherries require a winter dormancy period of cold weather in order to set bud. As such, their production is limited to the northern and the southern hemispheres in the temperate areas. The crop is also susceptible to frost in the springtime and heavy rain at fruit ripening, which causes the fruit to split. As such, their production in Northern Ireland is limited, and unfortunately, my travels did not bring me to Northern Ireland. However, I did travel to America, the Netherlands, France, Germany, Italy, and Chile. The generosity, openness, and kindness of the people I met on my travels was humbling and made me realize the similarity between the pressures farmers are facing worldwide. Around the world, farmers have adapted their growing system to suit their climate. For example, in the US, the main growing system was a 4-leader system, and they generally didn't use covers due to the dry summer conditions on the west coast and the high light intensity. By comparison, in the foothills of the Alps, around Trento in Italy, more intensive growing systems are used, with covering systems being commonplace. This is due to frost in the spring and heavier rain at fruit ripening and risk of hail. However, in the field, I did not see any robotics or mechanized systems happening. All fruit was hand-picked, with the only equipment being used being a bucket and a ladder, similar to what my grandfather would have used. By contrast, in the cherry pack house, millions have been invested in technology, with hydro coolers, cluster cutters, box tippers, packing lines, and state-of-the-art photo sorting for size, color, defects, and softness, with the fruit progressing through the line on sorry, I've gone too far now. Oh no. With the fruit progressing through the line on water flumes. Why has the technology in the field not kept up with the cherry pack house? The simple answer is that cherries are possibly one of the hardest crops to mechanize due to small fruit size, clustered fruits, and dense foliage, and complex tree systems. The harvesting mechanism of numerous crops has been mechanized over the last 100 years, from arable crops, potato productions, to sweet corn, to wine grapes, and milk production, to name a few. In my study, I specifically looked at sour cherries, strawberries, black currants, and blueberries. Sour cherries and cherries for processing are commonly harvested with tree shakers. These use vibration to dislodge the fruit, and the fruit is caught on a canopy beneath the tree. These are commonly used in Eastern Europe and Turkey. The vibration successfully dislodges the fruit. However, there's a high percentage of fruit damage as the fruit falls through the tree, which damages as it hits the branches on the way down. This is why their use has not been adopted in the sweet fresh cherry sector. In addition, damage from the vibration arm tends to shorten the lifespan of the tree. So I can just grab some water now. Thank you. In strawberry production, in the last 5 years, several robotic companies have endeavored to mechanize strawberry picking. Strawberries, similar to cherries, have a soft flesh and are generally hand-harvested with the stalk on. Robots are now capable of picking strawberries, as demonstrated by this dog-tooth robot in Scotland. However, I believe this technology is not currently commercially viable due to slow picking speed and high ratio of on-site engineers to robots. This technology is still in its infancy and will continue to develop. However, the timescale for full commercialization is unknown. For the last 40 years, blackcurrants have been harvested mechanically. These machines use vibration to dislodge the fruit before it's conveyed to the handling containers. In order to minimize the damage to the fruit, the bush is lent to a 45-degree angle to reduce the fall distances. This machine can pick 20 to 22 tons in a day. Similar vibration and catch technology is available for olives, coffee, and wine grapes. In the last 3 years, a number of blueberry harvesters have entered the market. These either use fans with air pressure to remove the fruit or vibration with hard plastic fingers, similar to the blackcurrant harvesters. The key to success seems to be to reduce the fall distances to minimize the amount of damage that occurs to the fruit. Could similar vibration technology be used in cherries? From my study, I concluded that there were 2 possible options for the cherry harvest to be mechanized. The first option is individual fruit removal using robots. Humans and plants have evolved together for millennia. As such, humans are very skilled at fruit picking. They are dexterous and autonomous. If robots are going to be commercialized, fruit picking or growing techniques and robotic capabilities will have to evolve together, with the robots working within the agronomic capabilities of the plant and vice versa. If robots can be commercialized in strawberry production, this technology could easily be transferred to cherries. However, the robots will not be able to access the cherries in the middle of the tree. Therefore, cherries will need to be grown on a single plane canopy system, like a UFO system, or more commonly known as a wall of fruit, which will make the fruit available to the robots to be picked. On the basis it takes 4 years from planting a cherry tree to the first commercial harvest, growers should consider these growing systems now. The second option is the possibility of mass harvesting using vibration. For this to be successful, fall distances have to be reduced to below 1 meter in order to minimize the amount of damage to the tree, to the fruit. Would it be possible to develop a wide trellis growing system with a UFO system based on 70 degrees? The advantage of this sort of system could be cost savings up to 40%. The disadvantage would be increased damage to the fruits compared to hand harvesting, and the fact that most of the cherries will come off stemless, as the force to remove the cherry from the stem is less than the force to remove the stem from the branch. Concerns about stemless cherries relate to perceived reduction in shelf life and marketability. In terms of shelf life, I conducted a simple study in 2023 to compare the shelf life of a basket of stem-on cherries and a basket of stemless cherries. After 42 days, there was no material variation in fruit quality. In terms of marketability, the concern is that a cherry without a stem is just not as sexy as a cherry with a stem on. For certain parts of the world, particularly Asia, a stem-on cherry is considered a prerequisite. However, in the US, market research has shown that consumer purchase decisions are based more on a preference over price and shelf life over the preference for a stem. And in Europe last year, over 5,000 tons of stemless Picota cherries from Spain were successfully sold as a premium product. This suggests that concerns about stemless cherries could be unfounded. Now, neither option is currently available, and the industry will have to continue with a bucket and a ladder for the time being. However, I believe it's only a matter of time until someone develops a harvesting and growing system for sweet fresh cherries. My message to the UK cherry industry is to keep a watchful eye on the emergence of these new technologies, and I have 4 recommendations. Firstly, growers should engage with robotic companies, principally to explain the advantages and disadvantages of the different growing systems. Secondly, for new orchard plantings, growers should consider robotics. The technology is not currently available, but is likely to be within the lifespan of the orchard. Thirdly, the industry should consider undertaking market research into the marketability of cherries. And finally, the industry should consider collaborating to develop a wide trellis growing system that could be suitable for mass harvesting using vibration. Thank you for listening. I look forward to your questions.